Let's start the first problem. Here we have to find out the inverse Z transform. I think we know this formula. A to the power k u of k. The Z transform of this is 1 by 1 minus a Z inverse. This is quite similar like this. Okay. So by the use of this formula, we can calculate the inverse Z transform, that is 0.2. That is similar like the A as given in the formula to the power k, as 5 is multiplied here, so we have to multiply 5 also here. So this match with the option number A. This is the correct answer. Okay. Now go to the next problem. This problem says that according to the sampling theorem, the critical sampling period T is related with the maximum frequency f of m h. As we know from the Nyquist sampling criteria, the sampling frequency should be greater than equal twice the maximum frequency present in the signal. So here the maximum frequency, that is fm. Okay, sampling rate, sampling period is given t here. So sampling frequency is 1 by t. So this sampling frequency will equal twice the maximum frequency present in the signal. So if we manipulate this relation, so we will get t equals to 1 divided by 2 times fm. Okay, so this relation match with the option number C. So option number C is the correct answer here. This problem says that the Fourier transform of f1t is equals to f1 omega, and the Fourier transform of f2t, that is equals to f2 of omega. Now a relation is given here. Look at this. Here the four options are: this is time shifting, frequency convolution, or time convolution. Look at this convolution part. This is the convolution between two Fourier transform signals. So convolution in frequency domain. So this will be obviously frequency convolution. So option C is the correct answer here. We have to find the average of given signal f of t. So for finding the average, we have to remember that for sinusoidal signal or for cosinusoidal signal like this, average value is 0. The average value of sinusoidal signal and cosinusoidal signal obviously 0, as because the positive part in a particular cycle, the positive part is equal to the negative part. So average value is 0 value. So the average of these and average of these is equals to 0. So the average of f of t, that is equals to 2 here. Okay, so option D is the correct answer. This question says that what are the time constant of the following systems? So for finding the time constant, we have to represent the G1s and G2s in the time constant form. So what is time constant form? That is k, that is constant, divided by 1 plus tau of s. This tau is the time constant. Look at this. G1s is already represented in the time constant form. So tau 1 for G1s, that is 0.4. This is for G1s. Okay. For G2s, we have to represent in time constant form. So for representing this in time constant form, let's we divide the numerator and denominator by 2. So it will be 4 by 2.5 s plus 1. So here 2.5 as the time constant. So answer is the 0.4 and 2.5, option C. This problem is from concept of root locus. So these are the axes. The root locus of g of s equals to 1 by s square, means two poles are present on the origin. S equals to 0, two poles are present at s equals to 0. So now we have to find out the number of asymptotes. The number of asymptotes are number of poles minus number of 0, that is equals to 2. So two asymptotes are present here, and we have to find out also the angle of asymptotes. So the angle of asymptote is 2q plus 1 multiplied by 180 degree divided by p minus z, where q equals to 0, 1, 2, it is a consecutive values. So calculate the angle of asymptotes here. For q equals to 0, that is 2q plus 1 into 180. So 180 by 2, that will equals to 90 degree. Another angle of asymptote is at q equals to 1. So at q equals to 1, that will be 3 into 180 divided by 2. So it will equals to 270 degree. So two angle of asymptotes are 90 degree and 270 degree. Let's try to draw the root locus plot. Two poles are present here. One angle of asymptote is 90 degrees, so it will follow this line. Another is 270, means minus 90, it will follow this line. So follow this line, and another pole will follow this line. These two poles will go to the virtual 0, which are present at the infinity. So the correct answer is that vertical straight line passing through 0 point, passing through 0, 0 means origin. Option D is the correct answer according to the root locus diagram drawn here. It's a simple problem based on number system. We have to convert octal number to the decimal number. The basic technique of converting any number to the decimal base or base 10, that is, the procedure is that we have to multiply it with the power of that base in which base the number is present here. So convert this, it will equals to 8 to the power 0 multiplied by number present is at the unit place plus 8 to the power 1 multiplied the number present at the 10th place, that is 2, plus 8 square multiplied by the number present at the 1000th place, that is 3. So after calculating this, it will equals to 64, 8 square 64 multiplied by 3, that will equals to 192. Then 8 multiplied by the 2, that is 16, and remaining 3 multiplied by 1, that is equals to 3. So the summation of this to 15. So sorry, so the correct answer is 215, option B. Next question says that deflecting torque of a moving coil instrument depends on the formula of deflecting torque, that is Tt, of a moving coil. Moving coil means PMMC instrument. Okay, the formula is that PINA, where B is the magnetic flux density, I is the current flowing through the coil, N is the number of turns, and A is the area of the coil. Here, according to this question, if we multiply V and A, deflecting torque is proportional to the multiplication of B and A. We know that B equals to flux per unit area. So multiply this again by area, so it will comes the flux. Okay. So the deflecting torque, that is Tt, proportional to the flux. So flux in the coil. Option C is the correct answer here. This problem says that we have to identify the symmetry, what kinds of symmetry present in this signal. So the procedure for finding the odd symmetry and even symmetry is that if f of t is equals to f of minus t, that is called the even signal or even symmetry. And if f of t is equals to minus of f of minus t, that is the odd symmetry. Okay, now come to this problem. Let's see. So I zoom in the problem for understanding better. F of t, suppose at this particular point the value of f of t, this is this, and for minus of that at this particular point value is this. So value at this point and this value both are equal in magnitude but opposite in sign. So we can clearly say that in this signal f of t is equals to minus of f of minus t. So this is odd symmetry, not even symmetry. Okay, so option C is the correct answer. If the signal was like this, suppose the signal was like this kinds of signal, that will even symmetry. Okay.